Ah, the famous Mobius strip. An object so many people have come across, but surprisingly few have given much thought to. Much less taken a pair of scissors to. If you want to be organised, I definitely recommend pre-cutting some strips of paper for this particular exploration. You'll want it so that they're long enough that making a twist before you wrap it back around on itself is easy enough to do. Of course, you should make sure that your explorers do actually only make one half twist before they loop it back together so that they end up with a Mobius strip. Because if they make a second one, cutting down the center will give you a very different result. And if they make a third one, it'll give you a different result again. Have a think about that. In fact, if you've got students that are racing through this ahead of everybody else, ask them that exact question. That'll give them something to chew on while everybody else catches up. Now, question 2 sheds some light on the first wonderfully surprising property of the Mobius strip. Namely that it's a manifold, by which I mean loosely that you're making it up by taping pieces of paper together in a smooth sort of way. Namely that it's a manifold that has exactly one side. So what do I mean by this? Well, if this is a piece of paper, it has two sides. There's a front and a back. And the only way to get from one side to the other, if you were an ant, is to precariously crawl up over an edge. Same sort of thing happens if you're a cylinder. Again, there are two sides. There's sort of an outside and an inside. And the only way to get from the inside to the outside is to precariously crawl over the top. Well, the Mobius strip is different. I can get from this piece here to the inside piece simply by walking along, and I never have to cross one of the edges. That's kind of crazy. Let me just say that again. I could get from this side here, this apparent outside, and walk along the Mobius strip and end up on the apparent inside. There is only one side to this Mobius strip. I can get from either side of this without having to cross over there by simply walking around the whole piece. That's kind of crazy. A piece of paper with one side? That's more or less all I really want to say about the one-sidedness of the Mobius strip at this point. There is, of course, a lot more that we could say, and if you've got a bunch of explorers that are racing ahead of everybody else, you could ask them to take a piece of paper and see if they could stitch it together in some way using tape to make another manifold that's just got one side. But as I said, that's just a lovely side tangent, because I want to get to the crux of this exploration. And the crux of this handout is to make sure everybody has a guess about what will happen before they take their pair of scissors and cut along the line down the center of this Mobius strip. Will we just get two smaller Mobius strips? Sort of in the same way that we got two smaller cylinders when we cut our cylinder in half? Have them think about it. And what does happen? Well, I assume you did the exercise.